Okay, we're going to jump into lesson 12.2, which is on systems of linear inequalities. And this is going to be pretty similar to a lesson we did a couple of days ago, which was on graphing linear inequalities. Now it's just a system of linear inequalities. So we're going to have two lines that we're going to have to graph here, and then we're going to see where this shading intersects. So let's take a look at the first one here. Notice that the equations that I have set up, or the inequalities I should say that I have set up right now, are already in slope-intercept form. The only difference being that instead of an equal sign here, we've got our inequality symbols. But it's still going to be the same process. We're going to start by identifying the b value, which is my y-intercept. So for this top inequality, we have the b value as -4. So I'm going to start at -4. And then I'm going to go ahead and graph using my slope here, right? My slope is 1/2, so that's up 1 and over 2. Okay. And then once I have those 2 points, I can go ahead and draw my line. And now notice I'm going to draw a dotted line. Hopefully you remember this from the past lesson, right? The reason that I'm drawing this dotted line or this dashed line is because if you look at my inequality symbol here, it's just a greater than symbol. It doesn't have the or equal to bar underneath, so that's why it's just a dotted line there. And now we're going to go ahead and do some shading here. So for this one, I'm going to have to shade above my line because notice this is a greater than symbol. So remember, if it's y is greater than, then we want to shade everything above the line here. So I'll go ahead and do that. And so that's going to be everything in this area here. So everything above the line. Okay, and then we're going to have to graph my next line here. And that's going to be a y-intercept of +6. So we'll start at +6. 1, 2, 3, 4, 5, and 6. And then we have a slope that's at -2, right? So that's going to be down 2 and over 1, right? I'll write it as a fraction there. So down 2 and over 1. And now for this line, we're going to have a solid line because notice we've got the or equal to bar there. So we're going to have a solid line there. So I'm going to go ahead and draw that. Okay. And now we have to decide where to shade for this one. This is a y is less than or equal to, right? So we want to shade below that. So that's going to be on this side where the line is falling down below it. Okay, so we'll go ahead and do that. And I'm going to do that in different color. Okay, and so that's going to be everything that's down here below the line. Okay, and then what we can see here is that we've got 4 different sections basically. We've got this section right here, which just has the green shading, right? Then we have this section here, which just has the pink shading. We've got this little section that doesn't have any shading in it. And then we have this section here that has both the green and the pink shading, and that's going to be my solution set in that area right there. So the solution set is going to be where the shadings overlap or intersect, right? So any point from that section is going to be a solution to this system here. So this is the solution set. So any point in that area. So if I picked out, like, let's say the point 0, 0, that would be a solution to this system of inequalities, right? But if I pick out a point that's down here, let's say this point right there, right, that won't be a solution to the system. It's only a solution to the pink shading, right? Not to both of them. So it wouldn't be a solution to the system. All right, let's move on, kind of recap that. That's kind of an intro there. Okay, and then it says a blank of a system of linear inequalities is an ordered pair that is a solution of each inequality in the system. So this is just a solution. So it's got to be a solution to both of the inequalities in the system. And then we've got these symbols here, and we've talked about this before, right? If we've got the less than symbol or greater than symbol, then we're going to have that dashed line or dotted line And if we've got the less than or equal to or greater than or equal to, then we'll have just a normal solid line there. Okay, it's got some steps there that you can use to follow. It says graph the boundary line, and then you can test a point not on the line to see whether it's a solution of the inequality. So that's one way that you can do this, right? Or you can set it up like we did above and graph the two lines and see where the intersections lie. So for this one, what I'm going to do first is get these into slope-intercept form. That way I can start to graph them more easily. So for this top one here, I'm going to start by rewriting it off to the side. So it's 2x plus 3y is less than negative 6. And I'm going to go ahead and subtract 2x from both sides. So that's going to be 3y is less than negative 2x minus 6. And then divide everything by 3. And I get y is less than negative 2 over 3x minus 2. So there's one of my inequalities in slope-intercept form, right? You don't have to rearrange it, but I think it's easiest to graph it this way. And then I'm going to go ahead and rearrange my second one, the one below here. I'm going to start by adding 2x to both sides. So if I add a 2x to both sides, that's going to turn into y is less than or equal to 2x plus 3. And then I don't have to do anything else there, so that's going to be my second inequality there. And so now I'm going to graph both of these. So I'll start with the red inequality, and we can see for this one that my y-intercept is negative 2. So we'll start there, and then I have a slope of down 2 and over 3. So down 2 running to the right always, 3. Okay, notice we've got this less than symbol, so no or equal to bar there. So this should be a dotted line or a dashed line here. And then since its y is less than, I want to shade everything that's below the line. So since its y is less than, I want to shade everything that's below the line here. And remember, anything on the dotted line doesn't count as a solution either. So it's just things below the line in this case. Okay, and then we slide over here to the green. And we've got a y-intercept at positive 3. And we've got a slope that's up 2 and over 1. Positive 2 is up 2 and over 1. And then for this one, we've got the or equal to bar underneath, right? So this is going to be a solid line here. So we'll go ahead and draw that. Okay. And then since its y is less than or equal to, we're going to be shading below the line. So that's going to be on the right side here, the way that the line would fall down if it was a tree. So that's going to be below the line there. So I'm going to do all the shading that's there. So that's going to be everything on this side here. And we'll start to shade in there. Okay, and then once again, we kind of have these 4 sections here. Okay, so we've got the section that's just green. We've got the section that's just pink. We've got the section with no shading, and then we've got our solution set down here that's kind of like this triangle here, right? So any point in that solution area where the both shading intersect, that would be my solution set there. So any point in that area. Okay, keep it going here. Next one here, again, I'm going to have to do some rearranging, so I'll start there. So I'm going to go ahead and slide this equation over. It's x minus 3y is less than or equal to 3. I'm going to start by subtracting x from both sides, so I get negative 3y is less than or equal to negative x, because I subtracted it to the other side, plus 3. And now I have to get y by itself by dividing by a negative. So remember, when we divide by a negative with our inequalities, that means we have to flip the symbol here. So I'm flipping my inequality symbol, and then I get negative divided by a negative here, which is a positive 1/3 x, and then minus 1. All right, so we divided by a negative number, so we had to flip the inequality sign there. We end up with our slope-intercept form. And now to the second equation here, the bottom equation, start by subtracting x. And I get 4y is less than negative x, and that's plus 0, right? So I don't really need that. I can keep it there if I want to. And then divide everything by 4. And we're going to get y is less than negative 1/4 x plus 0 divided by 4 is still just 0, right? And of course, I don't need to write the 0 if I don't want to, okay? But it's kind of nice to see it there because that reminds me that that's going to be my y-intercept. So I'll leave it there for now, although it's not necessary. Okay, and now we'll slide over and start to graph these pieces here. So I'll graph the red one first. We've got a y-intercept at -1. And then a slope of 1/3. So that's up 1 and over 3. And then since we have the or equal to bar there, this will be a solid line. And then since it's y is greater than, we want to shade above. So I'm going to shade everything that's above that. So that'll be everything up here. Would be my shading. Okay, and then the second equation there, we've got a y-intercept that's at 0, right? That's why I left that 0 there. Okay, and then a slope of -1/4, so that's down 1 and over to the right 4. And then there's no or equal to bar there, so that's going to be a dashed line for that one. Okay, and then it's got y is less than, right? We're working over here, y is less than, so that's going to be everything below. So I'll go ahead and shade everything that is below the line there. So that's going to be everything underneath. Okay, and then once again, we'll kind of end up with these 4 different sections. It doesn't always happen that we have 4 sections, but it often does. We have this section up here. That's going to be just the pink section. Then we have this section down below. That's just green. We have this little section over here, this little triangle that's got no shading. And then we've got this triangle here that's got the shading overlapped, and that would be my solution set. So any point in this section here would be a solution to this system. All right, keep going here. This one looks a little bit different because notice right off the bat, we'll zoom it in here. We've got just x's here, right? So we've got x is greater than or equal to -3, and we've got x is less than 2. So we are going to make a note here. When it's just these x's like this is going to be vertical lines. So these are the undefined slopes that we had talked about before, and that's when it's just x equals or x is greater than or less than, right? Then there'll be vertical lines. So we're going to start the first one by going to the x-axis at -3, because that's the point that we have here, right? -3. So I'm going to go to the x-axis at -3 and put a point. And then we're just going to draw our vertical line straight up and down here. So when it's x equals, it's just vertical lines. So we'll go ahead and draw that. And notice here I drew a solid line because I'm still following those same rules. Since it has the or equal to bar underneath, it needs to be a solid line. And now we have to do a little bit of thinking. So this is asking me to identify numbers where x is greater than -3. Right, x is greater than -3, greater than or equal to, really. So if I look at my graph here, right, I want to identify, okay, well, which side of this line are the x-axis numbers greater than -3? Is that going to be to the left here, or is that going to be to the right? And hopefully remembering, like, these are the positive numbers, so these are the ones that are greater than, so that's the side I want to shade for this one, because this is where x is greater than -3. So that's going to be everything over here. And now we'll go to the next one. So this next one, we need a point at +2 on the x-axis. So we'll go to +2 on the x-axis. And this time we need a dotted line because it doesn't have the or equal to bar. And then it says x is less than -2. So if this is, or +2, so if this is 2, all the numbers that are to the left of that are going to be less than that. So we'll go ahead and shade everything to the left. Of that red line. Okay, and then for this one, you can see we have 3 sections, so a little bit different here. We have 3 sections. We have all the way over here on the left, which is just pink. Okay, then we have all the way over here on the right, which is just green, and then everything in the middle is going to be where my shading intersects, and that's going to be my solution set. So everything that's right there. So I'm going to go ahead and make that obvious. So that's everything that's in between here is my solution set. All right, keep it going here. Last one that we're going to graph. Okay, so same idea here. Start with the y-intercept and the slope. So we can see we've got for this first one here, the y-intercept at +3 and a slope that's 2. So that's going to be up 2 and over 1. So we're going to go to +3 and then up 2 and over 1. And then this needs to be a solid line. Okay, and I'm going quickly through that. Hopefully we're catching on here. And then y is less than or equal to, so that's going to be everything that's below. So I'm going to shade everything that's below that line. Okay. And then we'll move to the next one here. And we've got a y-intercept that's at -4. And then a slope that's up 2 and over 1. So hopefully you're noticing these are the same slopes, right? So that means we're going to have parallel lines here, right? Because these are the same slopes. So we'll have parallel lines. And if this wasn't a system, that means that these would have no solution. But since this is a system of linear, or if this wasn't a system of linear inequalities, this would be no solution. But since it is an inequality, we have to determine where our shading lies. And so for this one, we're going to have to shade y is less than 2x, so that's going to be below the red line. So everything that's below there. And so again, we can see we have these 3 sections. We've got 1 up here with nothing. We've got 2 that's in between that just has green. And then we've got 3 where it's got both. And so this would be my solution set. So everything in this area would be my solution set because that's where the intersection of the shading occurs. So all of this area down here. All right, and then last one I want to point out here, they're going to ask you a couple questions on your homework that look like this, where they're asking you if this given point satisfies this system of linear inequalities. So the given point that they're asking you to identify right now is 0, 0. And so what you can do, remember 0, 0 is just an x and a y. You can just plug that into each one of these inequalities and see if it satisfies the given inequality. So 0 for y, 0 for x. I'm just going to punch that in for x and y in this top equation here, or top inequality. So it looks like this: 6 times 0 minus 22 times 0 is less than 9. Okay, and that would just be, well, this would cross out because that's times 0, and this would cross out times 0. So this would just turn into 0 is less than 9. And so you're asking, does that satisfy? Is that a true statement? So that's yes, so that does satisfy. Satisfy. Okay, so that's what it's going to say right here on this drop down menu. So you would just say 0, 0 does satisfy that one. And so let's go to the next one here. Same idea, we're going to plug in 0, 0 except into this bottom equation here. Okay, and so I'm going to move it off to the side, so it's going to look like this: 7 over 2 times 0 is greater than or equal to 7 times 0 minus 12. And so this is just going to turn into 0 is greater than or equal to -12. Again, does this satisfy? Is this a true statement? Yes, because 0 is greater than or equal to -12, so that is going to satisfy because it's true. Okay, and again, that's what you would select from this drop-down menu here. And since it satisfies both of them, then we can say that it is a solution. It is a solution of the system, right? If it only satisfies one, then it doesn't count, but if it satisfies both, right, then it is a solution. All right, thanks for watching.